Hello friends, welcome to DGS classes. I'm Dr. GAURAV Sharma and I'm taking you this chemistry class, and today we'll talk about preparation of phenols. So now let's talk about preparation of phenols. First of all, what is there is given in your NCERT. So predominantly these are the preparation of phenols. So phenol, also known as carbolic acid, was first isolated in early 19th century from coal tar. These are pretty important point if you are preparing for NEET exam and for BITSET also. So nowadays phenol is commercially produced synthetically in the laboratory, and we have these three processes from halorine, from diazonium salt, from benzene sulfonic, and finally cumene process. So let's go through these things one by one. So number one, from chlorobenzene. So today we are going to study preparation of phenols, and number one, from chlorobenzene. Number two, we will discuss from diazonium chloride. From benzene, diazonium chloride can be abbreviated as BDC. Okay, so my dear students, first of all, let's talk about how we can convert chlorobenzene into phenol. And we all know that it's pretty difficult for an aromatic compound like benzene to give this nucleophilic substitution reactions, because at one glance it is pretty clear that we are actually removing what we really want. This is our chlorobenzene and we want it to convert into phenol. So now at first glance it is pretty obvious that Cl minus, the chloride ion, will act as a leaving group and OH minus will occupy its position. But as we all know that these things are pretty difficult, as an aromatic compound will actually oppose this sort of nucleophilic substitution. And why is it so? Just look at this. This chlorine, there are basically two reasons what we can classify, we can categorize as. Number one, this chlorine has some unpaired electrons, what you can say these lone pair of electrons, and they can exist. We can draw it like this. They can exist, what we can say, in the process of resonance. They are actually involved in the process of resonance with this aromatic ring. Due to this carbon and this chlorine will acquire a certain, what you can say, a double bond character. And the next thing is, as we all know, that each carbon on this benzene ring is basically an sp2 hybridized carbon. Because of this double bond, because of this high density of electron, then can you imagine that a nucleophile is coming towards to replace the another one from this benzene ring. Benzene ring itself is a species with high electron density. So there will be a strong repulsion between the incoming nucleophile and this benzene ring. So these are the two hurdles. So generally, benzene ring does not show nucleophilic substitution reactions. So the number one is because of the involvement of the lone pairs of the atom attached there will be a double bond character which will actually hinder this nucleophilic substitution. And why is it so? Because there will be a strong, what we can say, the strong bonding between this chloride ion and this aromatic ring. Now, how can you separate them? So, like I said earlier, for this nucleophilic substitution, we really want a good leaving group. If you don't want to continue with a relationship, so either you will go for the breakup or the other person. So as we can see that benzene, if benzene wants to get away with this relationship, then it will acquire a positive charge. And the positive charge on a benzene ring will not be a stable one. Fine. What we have seen in our SN1 reaction, we have that tertiary carbocation formation, and as we know that tertiary carbocation is stable. Look at this, I am not talking about benzyl carbocation, I am talking about the positive charge on benzene itself, which is not a perfectly stable condition. So the chlorine and this benzene ring are involved in this delocalization of pi electron, which is better known as resonance. And because of this resonance, this chlorine and this benzene, they are bound together pretty well. And in this case, chlorine is not going to, behave as a good living reagent. The second thing is benzene itself is a nucleophile. So how can we believe that it will allow a nucleophile to come towards it? There's going to be a strong repulsion, so it will repel. Maybe the second point is somewhat not clear. I because of my own image on the screen, I will take care of it next time. So it will repel the incoming nucleophile. So as it is clear that benzene generally doesn't feel good about this nucleophilic substitution, but as we know that we have to convert this chlorobenzene into phenol. How can we do it? So my dear student, actually we are talking about sort of nucleophilic substitution in aromatic compound. So now let's talk about nucleophilic substitution in aromatic, SNAR. What are the different possibilities and what is actually the mechanism of this reaction? So, and this reaction is to be called as nucleophilic substitution in aromatic compounds. So now let's deep dive into it. First of all, let me introduce you the reaction. It simply has this chlorobenzene, and then we react this with aqueous NaOH with very high temperature, 623 Kelvin, and a very high pressure. So what we can simply assume that benzene is something like a very naughty student, and we want to convert chlorobenzene into phenol, but he's not ready to do it. He doesn't want to get transformed into this. So we will actually heat it, apply a whole lot of pressure, and then by using this will gets converted into phenol. You might think it like this. And as someone who really don't want to get into the details of this reaction, who just want to study for their boards, this much is enough. But for those who really want to get a feel of this reaction, who really want to know more about the reaction, for those I'm going to continue with the mechanism. And let me tell you, my dear students, many a times we do not we don't recognize that just by remembering something, just by memorizing something, we cannot develop a very good career. And I'm coming up with another video for IIT JEE aspirants, where I have heard of, again a news that some people are involved in cheating sort of in JEE mains. And this is something a very bad habit, because by cheating you can get through this exam, but you cannot get that property of a thinker. And until and unless you can think pretty well, you cannot develop your career. So this is something which you should know. As I was explaining, that as you can assume chlorobenzene as a very difficult student who really don't want to study, but you want, as a teacher, you want him to remember certain set of equations. So you apply pressure, you try to scald him by increasing, as you can say, the temperature, and by using these tactics, it will get converted into, it will show that nucleophilic substitution reaction. In India, We have a very strong culture in Haryana where we believe that if a child is not able to understand anything, then a personality within the family will come and increase that pressure with a very high tone of voice, and that person will be considered as tau. So what we can assume that in this reaction, look at the coincidence. In our Indian society, we call it as tau, the person who really control and put pressure on that kid to perform well. And in this reaction, the person who gave this reaction is known as Dow. So this is Dow's process. Sound pretty similar as tau. This is Dow. So this is known as Dow's process. So this is something, a way to remember this reaction. But now let me tell you the real nitty-gritty of how it actually occurs. So let me explain you the mechanism. Okay. So what can be the proposed mechanism for this? Look at this. We have a pretty high temperature and a strong base like NaOH. And as you all know, I've been a very big believer in this, that all reaction in organic chemistry are basically acid-base reactions. So we have one base with us, NaOH, and what base will really want? Obviously, an acid. So you can think like this. Let me draw it. We have this. Chlorine is located in this position, and we have these hydrogens present on the benzene ring, and one OH minus really want to get that H. It's something that OH is really very hungry. He really want to react with this hydrogen. After removing this hydrogen, benzene again acquire a positive charge, which is because benzene will acquire a negative charge because OH minus will want this H plus, and after removing H plus, the benzene ring will acquire a negative charge. So what we can think of, that this H will get removed by losing this charge here, which we can think like this. Again, let me redraw it so that you will get a better idea. We have this chlorine and this carbon. We have these hydrogen present. And when we have one hydroxyl, that is OH minus. OH minus, because NaOH is a base. What OH minus wants? All it wants NH plus. There is NH plus. When H plus goes out, something is coming out with a plus charge. It will leave behind a negative charge. So a negative charge will present here. But as we can understand that there is a carbon with chlorine just nearby, what we can say, the carbon which loses H plus has an alpha, carbon which loses H plus has an alpha carbon which contains chlorine, and chlorine is more electronegative. Then what will happen? The chlorine will comes out with a negative charge. And what we get? Let's say if this H comes out with this OH minus to give us a molecule of water, this bond will break. There will be a negative charge. The negative charge will form a triple bond, an extra bond, because we already have double bond. So an extra bond will be formed, and this chlorine will come out with that negative charge. So what we will get? We'll get something like this. The name benzene itself sounds that it is actually an alkene, benzene. And now, as a triple bonded structure in case of hydrocarbon is considered as alkyne, this will be termed as benzene. pretty easy to understand. Just go with the flow. Look at that. All reactions are acid-base reaction. One OH minus comes. What it wants? It wants just H plus. Acid-base reaction occurs. H plus is coming out, leaving negative charge behind. But as we can actually predict, chlorine will be a better contender for that negative charge. So what will happen? This will comes in this, and the chlorine will leave out as a good leaving group with this negative charge. And we are left with this benzene. Some people call it that it will follow a benzene mechanism. It is pretty obvious. We need not to remember all these things. It is pretty obvious. Is it clear, my dear students? I know it is not a live class, but it is something my habit. So what we now know that the reaction which seems to be pretty easy, is it actually easy? Because it will follow an acid-base mechanism. The OH minus will try to capture that H plus, and as we can pretty well predict that because of high temperature, even both of these are pretty much reactive, and under normal circumstances, under ordinary condition, this reaction will not occur, but at high temperature this reaction will occur. And that is why we provided 623 Kelvin of temperature for this reaction, and under high pressure also. So these are actually known as drastic conditions. So this is my benzene. Now let me tell you, as this benzene contains this triple bond, it actually makes this structure linear. This part is linear, the other two are actually planar, and benzene really wants to remains planar, so that this aromaticity, the property of aromaticity, will remain with this benzene. So now this structure is pretty unstable, and it is highly reactive. Now what will happen? As we can assume, we are pretty well versed with this sort of addition reaction. So it will call for an addition. And what kind of addition will be possible? Just check. Both of these carbon has that equal probability of addition. So what can we think of? We can think of that now NaO minus H plus. This is not the way particularly what we can say. This is not actually how this NaOH minus will get dissociated. But let's consider it like this. And somehow the mechanism is pretty different, because the water molecule will provide one H plus, and then ONA minus will get towards to hit it like this, just on the pattern of this Markovnikov addition, because now an electrophilic addition will occur. So what we can think of, that now this double bond will remain. One side will acquire the ONA minus, and this one will get the H plus from the water itself. So now this ONA. So this is what? Phenoxide. This is what? Phenoxide. What you will have to do? You will provide it with H plus. Okay, some sort of H plus can be guided from the water itself again, and you can provide it this HCl, and finally you will get this OH. So this is the whole mechanism. This is the benzene mechanism, which is actually can be proposed for this Dawes process. So this reaction is pretty easy for board's point of view. This much is enough. For those who really want to make a difference, the whole mechanism is important, which is pretty easy. Okay. And one more thing I would like to suggest. If somebody is really preparing very hard for competition and for his or her life. So let me tell you, there is some sort of addition which is known as Sine addition. Sine addition. Okay. So what this Sine addition means? Like I said earlier, both of these carbon will have equal probability to get this ONA or H plus. Fine. Because both of this, like in case of Markovnikov addition, we know that the carbon with higher H or with lower H or with more stability, both of these are actually allylic. So both of these are actually what you can say showing similar sort of stability. So both of these can get this ONA. So let me tell you, the chlorine is present on this carbon, and the possibility of getting OH at this or to its nearby carbon, this carbon, is 50-50. That means certainly you will get phenol, but there is equal chances that the carbon from which the chlorine is coming out will get OH, or the nearby carbon will get OH. Both of these can get this OH. And this addition, where the incoming agent, incoming nucleophile will, what you can say, will join the carbon. And the carbon which is not the initial one, which is not the previous one. This sort of addition is known as sine addition. So in this case, we can easily assume that as the benzene formed provided the equal opportunity for both the carbon, so we can have this or this. You can say, sir, what it is? Is it really making any difference? Yes, it is making any difference. It is definitely making a difference. Let's say this carbon is carbon 14, a radioactive carbon. So there are 50% chances that this radioactive carbon will get this OH, and there are 50% chances that the carbon next to this radioactive carbon will get this OH. So let me tell you, if you really want to understand the concepts, then you have to be ready with these sort of things. So this is a pretty easy explanation of Dow's process, what is actually the Dow's process is, and how it can be considered as the aromatic substitution reaction. And this is sine addition, and this is benzene mechanism. We do have this SN1 mechanism also, because now we are talking about nucleophilic substitution in aromatic compound. So, sir, yes, we can think of the mechanism of SN1, but how we can achieve this SN1 or nucleophilic substitution in aromatic compounds? Let me tell you a simple thing, a simple sort of what can say the information. We all know about benzene, diazonium complex reaction, or what we can say the benzene diazonium chloride reactions. We all know about it. My dear students, most of us will really feel pride just by getting good marks in our school exams. Does it really make sense? If you don't know anything about the reaction, just only a little, that by using this we'll get this, by using this we'll get this. It's something like, I'm going to the gym and I know that this will be used for for bicep curling, the dumbbell will be used to lift and to develop my muscles, but I'm not doing it. I'm not following the process. I don't know how it will be done. So is this any use? No. In the same way, in future, we have to follow a process. We need to understand the overall scenario, and then only we can adapt to that, what we can say, the uncertain atmosphere, uncertain environment. So for better adaptive ability, you need to know the complete process, so that where you need to tweak your situations, where you need to accept, where you need to oppose, where you need to say yes, where you have to say no, you will be pretty much thorough with all of these things. And organic chemistry somehow guide you to do that, just like mathematics. So now what is benzene diazonium chloride reaction? We all know that benzene, we will take benzene, we will react this with HNO3 or H2SO4, we will get nitrobenzene. Nitrobenzene can easily be reduced into, or FeSCl can be used, NH2. This is now aniline. And when we add NaNa2 SCl in aniline, we will get N2Cl. And by using Gattermann reaction, or maybe the Sandmeyer reaction, I will use Gattermann, then we will definitely get this chlorobenzene. Pretty easy, isn't it? Yes, sir, we know this. Yes, sir, we know this. Forget it. Forget it. What about knowing these things? Even Google and Alexa can guide me that this reaction can be done like this. The challenge is, okay, your board exam, for your board exam, this much is enough. And once you get this N2Cl, this N2Cl, this is known as benzene diazonium chloride. And when you add water into it, you will get phenol. So this can be used as a preparation reaction for phenol. Fine. What is the use of this? It can be, we can just type how we can, formation of phenol, what kind of reaction can be used. So you can definitely get this idea with everything written is on Google. So just by knowing something, you will not get anything. You need to understand the whole process. Now let me explain what is the whole process of this reaction. For those who really want to get prepared just for their exam, this much is enough. For those who really want to make a difference, let me go through this. Now, first of all, if we really do want that my benzene will acquire a strong positive charge, what I really want, I want that for SN1, we are actually hoping that benzene will undergo SN1 substitution, okay, nucleophilic substitution type 1. What we really want, then there will be a positive charge on the benzene ring. Now, what is the possibility? Definitely, like I explained earlier, if you really want to break a relationship, either you have to quit or another person will leave you. In normal circumstances, anybody who is more stable is going to leave the other person. Fine. So in our SN1 reaction in alkyl halides, that was the substitution taking place on saturated carbon atom. So at that point of time, the tertiary carbocation is more stable after leaving that chlorine. So that is why what we can say that in that reaction, the substrate is enough. He can leave chlorine. But now, my substrate, my benzene, doesn't want to form this. Because the positive charge on a benzene ring doesn't make it stable. So now what's next? The another person, another individual, it is more capable, then only this positive charge is possible. So in short, what we need a good leaving group. Repeat it. We need a good leaving group. Again, repeat it. We need a good leaving group so that my aromatic compound, my benzene, will show SN1 reaction. How to go about it? This is possible only when, not only is not going to be the proper word, but at this point of time, we are actually, having this reaction only. So if this N2 plus is there, and we provide a little bit of heat, this N2 will go away. And the benzene ring will left with a positive charge which can be easily acquired by something or something negative. So how this N2 plus can be provided to this benzene? Okay, so just go through this. We have this NaNO2 SCl. Our prime objective is to get this NO plus. Our prime objective is to get this NO plus. NO plus is going to be pretty reactive as this species is this. How to get this? Okay, so this NaNO2, let me draw this. NaNO2, this is NaNO2, this is plus, this is minus, NaNO2. And what we have done, we added HCl into it. So this H plus will bind to this O minus, and what we will get? We will get this OH. Fine. Now we can easily assume that this is a different entity with Na plus, because now we don't have this negative, but again one more lone pair is present, so one more H plus will can get combined to this, and what we are left with, N double bond O, OH2 plus. Because the medium is acidic, we have this HCl. So as oxygen contains a negative charge or a lone pair also, oxygen is pretty much obvious choice for H plus. So this H2O will form, and now it is pretty obvious this oxygen will leave this plus charge to nitrogen and just removed as water. As this oxygen, this one, which is double bonded with nitrogen, it also has these two, what we can say, the lone pair. So it will donate one of its lone pair so that nitrogen will get rid of this positive charge, but in the process it will acquire a positive charge, which makes this whole species pretty unstable. So now we have this NO plus. What will be the next situation? Let's say we have RNH2. Because NO plus will not exist, it is pretty reactive, so we need something which can actually back it up. Now this oxygen wants its bond back again so that it will become stable. In this process, this nitrogen, we have this, what we can say, amine, alkyl amine for say. Now this nitrogen can donate its lone pair to this in the process so that oxygen will get its electron back. So what we will get? Very easy. But in this process now, if you want to help others, like in this case oxygen want to help this nitrogen, in this process oxygen acquire one positive charge. Now this nitrogen wants to help its nitrogen brother, so again this nitrogen will acquire a positive charge because now it is forming 4 bonds. Okay, fine. Now what can be the possibility? What can be the next possibility? So now this nitrogen can actually remove this hydrogen to form a double bond with this nitrogen. And why is it so? Because there is a strong possibility, because oxygen is there with its lone pair, and these two hydrogen are acidic in nature. All reactions are acid base reaction, isn't it? So this will create an intramolecular reactivity centers, because these two hydrogens are acidic and oxygen is present with with 2 lone pair of electron. So it is quite obvious that both of these can get separated and move out with this oxygen as H2O, and what we will get, that R N plus triple bond N. So this will and this double bond will be formed with this, but again this nitrogen is actually forming 4 bonds, so that is why it will definitely require this positive charge. Now what? This N2 plus wants to get out, leaving this plus charge behind. As this R is an alkyl group, it is not that much stable with that positive charge. Maybe there is, if this is tertiary, then it is going to be the better chance. But if this is a benzene ring, that means if this is an aniline, it will provide the best chance for this situation. So like we have this NO plus, we have this NH2, this lone pair will go to this, and finally we will get this N plus triple bond N. Fine, my dear students. So now what is the another possibility? So in this case, if you want to add H2O, so again H2O is having these 2 lone pairs. So what is going to happen next? The N2 will come out by forming nitrogen, and this will get attached to this positive charge and form this. Now this H plus will again start our reaction. So this is the whole soul mechanism of benzene diazonium chloride reaction and how it will yield the phenol. So for those who really don't want to get into the details, they can learn these two reactions. Basically, it is of no use. I'm not in a favor that you just learn this reaction and just like what we can say, you are in competition with Google or Alexa to just produce the data. I want you to understand the real concept and mechanism behind these reactions, and I hope you are getting it. I've started this, series, the LAKSHYA series, and for my 12th class students. And initially, I was taking classes in Hindi, and some of you still want that I will continue with my Hindi classes also. No, my dear student, I'm not that. What I can say, even I'm learning. I'm improving on my language, my English language, and this is a good thing because maybe I'm not perfect, and I really don't want to be get into the war that I'm the best and I'm the perfect. But this is what I really want to tell you also. Keep on learning, keep on devising new techniques. If you want me to continue with the Hindi lectures also, I will do that. I will continue my Hindi lecture on this channel, and very soon, in about after 12th of this September, that means after the day of NEET examination, I will get some more time. I will continue with both of these languages, in Hindi also or in English also. Okay, fine. But I really want you to cover everything in details with mechanism. Okay. And as I saw some videos on YouTube where people are actually giving in just information and not the mechanism. So I believe this is my duty to come up with proper mechanism or the proper system of learning. Fine, my dear students. So I hope these two mechanisms, the benzene mechanism or the BDC mechanism, is pretty much clear to everyone. All the best. So if you're still pretty new to my channel, please subscribe it, because very soon I'm going to start with the career series also. If you want to share, if you want the others to come and learn, you can share this video, because in our society we need to understand the proper meaning of career. Along with your study, I'm going to start with that career series pretty soon. All the very best. Take care.